My name is Patrick Santi, and I'm a computer music student in the fall of 2010 at Stetson University. Today I'm going to be talking to you about an algorithmic composition patch that my group and I made for our final project. First of all, we have to get MaxMSP to open, and we're just going to navigate to my patch. Okay, so right here you should be seeing a large view of our patcher, and specifically my patcher for the performance. If you look here, we've got this section, which is part of the Mobile Performance Group Care package that can be found at lowkeydigitalstudios.com. That should be in the comments. Don't worry about slowing me down. And this rhythm bank is included as well. We're using evolving life algorithms to generate note data, as you can see here. And then we evolve this data and share the data between the computers to create a linked dynamically changing performance. We start out, when the patch opens, creating a mutated list where any member of this list is replaced at random with any member of this list at a 20% probability. This starts our seed list, as you can see here. This seed list is then evolved in this evolve subpatcher right here, and these are the received pools from the other computers. These lists right here are just for your personal viewage. Right here, these probabilities are then quantized using a series of ZL and a random object into zeros and ones. These zeros and ones are then sent down here to this send matrix, which then puts them into a meaningful message format that the rhythm bank understands. So you can zoom in on this for you, see right here. If you need to go back at any time and pause the video to see the series of objects I'm using, don't hesitate. Okay, so that's basically how the rhythm bank is populated. Once we populate the rhythm bank, we need to choose the notes that we're going to be playing. This is done using a Brownian algorithm, as you can see here, the Brownian list pool select, which allows me to select the seed pools from either of the three voices so I can cross-reference them. In this subpatcher here, you see we've got the Brown melody object, which is courtesy of the RTC library. The total list data right here, the sum of the list, is sent into scale object, which scales it from 0 to 1, which determines our Brown factor. That's then output as a MIDI note, which is quantized into this modulo object, and then the MPG get scale mem max patcher determines the note that will be played inside of the chosen scale, and that's determined over here with this part. And I'm in slave mode right now because I'm not playing. So now that we've done that, we can actually start this up and play some music. Let's wait for it to turn around again. So you should be hearing a little bit through my microphone of some of the sounds that my patcher is creating. I can pan these left and right, control their levels, and things like that. I can also force them not to update, so that in case I particularly like a pattern, I can keep it around for an extra few cycles to give sort of a continuity. And here, let me turn on our... This is a rather picky additive synthesizer, well, semi-additive. And that's basically my patch. We went from beginning, list creation, evolution, concatenation, population, note selection, and the instruments, which could be whatever you wanted. In fact, when I post the code for this online, you could literally use any instrument you could think of that works inside of MaxMSP.
Alright, here's Austria, and here's my max patch. So, let's start out with this little module right here. This module, let's see, make sure I have it in lock mode. Do I have it in lock mode? Yes, I do. Okay. This little module is my Euclidean algorithm implemented, and this toggles it on and off. This generates the list data, and it populates the ribbon bank as well as the seed data that it's getting from Patrick and Mark from the Breed the Children button, which is why I have it right here. That toggles it. We can communicate through this little message center that Mark came up with. You just type in a message, test, and basically you toggle this back and forth to decide which to send it to. So in this case, I'm going to send it to Mark. Press enter, and it clears the message box. And I've just not sent a message to Mark. So, on to these toggles. These are my voices for the ribbon bank. And these are the sliders that when you turn them up, they will of course make a sound. This is my master gain with the Jamoma output. Let's toggle all of these voices. It's not necessarily toggling them on so much as if I like a pattern, then I'm going to keep it consistent in the ribbon bank so it doesn't change after each cycle. Here. And let's see here. Alright. So, as you can see, it's not really getting anything because it's not plugged into speakers yet, but it's besides the point. Hey, turn off. Turn off. Hey. Thank you. Okay, but okay. So, as you can see in the Euclid module, you can change your list values. That will give you a list of 11 figures, and 10 of those figures will be populated with on beats. Click them to set it, and in the next cyclical iteration, it will fill the ribbon bank with the appropriate list. Actually, let us see. Actually, I need to go to unlock. Now, object. Ha. This would be my Euclid patch. Still in presentation mode. And as you saw during my presentation, this is the nuts and bolts of the patch. This is the U menu that lets you select the elements of the list and the number of iterations you want. This spits out the list. It prepends it to the set, and it packs data from these coefficients into the U menu, and it runs it through this jar file. That's pretty much it. That is my patch. So, yeah. Ta-da.